In this lecture, we're going to discuss input and output, getting data, and essentially we've done some output. We're going to make our data pretty. All the programs we've created thus far haven't really allowed us any interactivity with the user. I mean, we've defined variables, we've set them to values, calculations are done, and the results are displayed. The user executes the program, but they're really just sitting back and watching. If we want to test different things, we want to run different things through the calculations, we've got to adjust the variables, compile the program, re-execute. Wouldn't it be nice if there are things if things could change, or if we wanted the user to be able to tell us what they wanted to test or calculate or anything like that? Wouldn't it be nice if we could have them choose the data? And that's what we're going to talk about this evening. We're going to talk about ways we can get information from our users, and then of course how we can control or make pretty what we're going to talk about or what we're going to display back. So we're going to start off with getting input from the scanner class. The scanner class is a group of functions or functionality that allows us to get data from the command prompt. The command prompt is essentially what we see in the output window in NetBeans. We're going to learn how to get input from the command prompt from the user. We're also going to talk a little bit about dialog boxes. The JOption pane class is a class that contains functionality for displaying various types of dialog boxes. These are those little pop-up boxes that you see that applications sometimes put up. A lot of times they have warnings. Sometimes they're asking you for information. In this case, we're going to learn how to get information from a user using a dialog box. We're also going to learn how to display information to the user using a dialog box. We're going to talk about ways to convert string data to numeric data. When we get data from the user using dialog boxes, it all comes back to us as a string of characters. And even if that string of characters is a string of numeric characters, we have to convert that into an actual number before we can do anything with it. Our wrapper classes give us that functionality, so we're going to talk about most of those. We're going to talk about making output pretty using some formatting classes or formatting functionality. The first one is called the number format class. It allows us to ask the computer how to format numeric data for currency or money, and how to format it for percentages. Every location displays things a bit differently, and it depends on the setup of your computer, how your computer's set up to display that information. Rather than having to figure out all the different ways to display that data, we can actually ask the computer, hey computer, how are you set up to display that data? And then the number format class has functionality that will automatically format any number that we give it, as long as we tell it whether we want it to be a currency or a percentage. The decimal format class gives us some functionality to define how we want that number displayed, right down to, do we want leading zeros? Do we want zeros after the decimal point? Do we want a certain number of digits after the decimal point? We have all of that capabilities with the decimal format class or group of functionality. The other way to format output will be formatting output at the command prompt using the printf statement. Up until now, we've used print line. We've seen it quite a bit. Print line, println. We've also seen system.out.print. I think your books used it a couple of times, and I've had it on a couple of slides, though we haven't really talked about it in depth. There is one additional type of print function, and it's called printf, and it stands for print format, and we're going to learn how to put together those sorts of statements. Finally, to use a lot, to use a lot of this functionality, we have to utilize libraries of classes or These groups of functions are organized together into even larger groups called libraries or packages. And we're going to learn how to use those packages because the scanner class, the J-option pane class, the number format, and the decimal format class are all part of a couple of different packages or libraries of classes that we'll be looking at. So we're going to learn how to put those in our program. We're going to start off tonight by talking about the scanner class. The scanner class allows us to collect input from the command prompt or terminal window, and the scanner class provides a number of different methods or functions, or commands if you will, that allow us to gather string or numeric data. We're going to look at each of these different types of functions in a few minutes. First, let's talk about where this functionality is stored. It is not available to us by default, so we have to let Java know that we want to access the library or package where this class and all of its functions are located. And to do that, the library name is java.util. Just keep that in the back of your mind. You'll see how we will use that when we practice with it in class. There are a number of different libraries we're going to talk about throughout the semester. We're going to talk about two different libraries tonight, java.util and java.text. And there are others throughout the semester that we will use. We won't talk about all of them. There are hundreds of different libraries available. When you talk about extended functionality, there's even more libraries available. But we'll touch on a few of them. You can go take a look at the Java SDK or the Java JDK documentation over at Oracle's website if you really want to see all of the functionality that's available. So let's talk about how the scanner works. When you type data in at the command prompt, it is stored in the keyboard buffer. The scanner class breaks that input down into chunks. These chunks are called tokens, and each of these chunks or tokens are separated by white space. White space is the return key, the space bar, the tab, the enter key. And we can use the scanner class functions or commands to convert these tokens into different types of data. There are a bunch of different functions or commands that are available to us. If we have numeric data that we want to get a byte back, now remember that a byte is a numeric value between negative 128 and positive 127. So as long as the number that the numeric token or chunk that was entered would fall within that range, then we can call next byte, and it'll give us back a byte. Remember again, a byte is an integer number between negative 128 and positive 127. We also have a short, next short, that'll pull out the token, the next token, that is numeric, that falls between a little over negative 32,000 and a little over positive 32,000. As long as the number falls within that range, we can call next short and get that data back. Next int, we'll get the next integer that is between negative 2 billion and positive 2 billion. It's going to look for a string of numeric characters in that buffer. It's going to look for the next token that is a string of numeric characters. And it's going to give that back to us as an integer. Next long is the largest integer, so it's going to look for the range that we had for a long data type. And if that number falls between that range and we call next long, that number will be returned to us as a long, or given back to us as a long value. We also have next double and next float. Again, that looks at the numeric value, that next numeric hunk in that keyboard buffer and gives it back to us as either a double or a float. Remember that a double is a decimal number, 14 to 15 significant digits or digits after the decimal point, whereas a float has 6 or 7 digits after the decimal point. Next, returns that whatever that chunk is up to the next white space as a string. So it sends it back to us as a string of characters. Next line does everything up to the enter key, and it treats that as one chunk and gives that back to us again as a string. How would we use the scanner class? Well, first we would create a scanner variable, if you will. It's really called an object. We haven't talked about those yet. So for the moment, I'm just going to keep calling it a variable. We'll learn about objects a little bit later in this course. But we're going to create this scanner variable or object, and then we're going to call the methods that we want to use. We're going to call those scanner object commands using the variable that we created. So, for example, if you look at the code that we have here, I have a class named age. You'll notice on line 8, what you see is import java.util.star. What this line right here on line 8 says is that I am importing the package, the java.util package. This .star means all the classes that are stored within it. I'm importing this java.util package so that I can get access at this scanner class right here. So I've called the class age, and notice that the import statement comes even before the class definition. The first thing that Java needs to see is what additional libraries it's going to need in order to make this program run. So we're going to go ahead and then define our class, and I've called it age. Inside our main method, first I'm creating a scanner variable called keyboard, and I'm saying new scanner system.in. For the moment, this is really called a constructor. We'll talk about constructors when we talk about classes. For the moment, though, I just want you to concentrate on the fact that anytime we're using a scanner variable, this line right here, everything from the equal sign on, needs to be exactly how you see it on the screen. We'll talk about why that is a little bit later in the course. But for right now, I'm just going to need you to sort of take it on faith that this is what you need to do. Keyboard was a variable name that I came up with just because it was getting the input from the keyboard at the command prompt. I thought that would be a good name for it. I'm going to display a message to the user, essentially prompting them to provide me their age. Then I'm going to call keyboard.nextInt. Now remember, the user is going to type in some number after my prompt, and that number is going to go into that keyboard buffer. And what I'm saying is read out of that keyboard buffer the next integer. And since this returns a value or gives us back some information, I'm going to store it in a variable I created called age. Since I'm calling nextInt, and I know that it gives me back an int data, a number that falls within the range of an int data type, I'm going to store it in an int variable. And then my last line, I'm simply printing out UR, and then the value of age, and then the number of years old. This may seem kind of complicated. We will go over a couple of activities like this in class, just so you can see how this all sort of works and how it all plays together. The scanner class isn't our only way of getting input. I really like the scanner class. I think it's simple. I think it's elegant. I think it provides us with the ways to get input from the user at the command prompt. But one of the things that sort of turned me off to programming was consistently doing everything at the command prompt. That's not useful. People don't work that way. The programs that people use every day are not object-oriented, but are visual programs, right? They're graphical user interfaces. They have buttons and text boxes and check boxes, and they respond to not only keyboard input, but also the mouse. And so I think it's important at this point in time that I introduce you to some GUI elements, some graphical user interface elements. And the first thing I want to introduce you to is the dialog box. And we get that through the JOption pane class. The JOption pane class has functionality that lets us display various types of dialog boxes. Again, this class and its associated functions are stored in a library. It's not included by default. We have to let Java know that we want to use it in our program. The name of the library that this class is stored in is called javax.swing. Keep that in mind because if you ever need to use it, you're going to need to know its name when you go to write your import statement. The JOption pane class works by calling one of the show dialog methods. There's a show input dialog, a show message dialog, along with a couple of others. We're going to concentrate on show input now, show message a little later in this lesson, and then we may get to the other ones later down the semester if we have time. These methods will display a dialog box to the user, could ask the user for some input, could just simply display some information to the user. To get input from the user, we call the JOption pane's show input dialog method. It takes a couple of pieces of information. First of all, it needs to know what window owns this dialog box. For the most part, when we're using this, at least right now, we're going to provide it with the keyword null, N-U-L-L. Again, null is a keyword. That'll be the first piece of information. We'll have a comma. And then what do we want to display to the user? What are we asking the user to enter in? Are we asking them to enter their name? Please enter your name. Please enter your age. Where you see message on here, we're going to replace message with what we want the prompt to be. What do we want to display to the user? What question are we asking them to answer? The other two options here are optional. Every dialog box has a title bar. If you look at any of your programs up at the top, whatever the top of their window is, you'll see a little icon and then the name of the program maybe, and some information about what you're currently doing in it. Like if you're in Internet Explorer, you might at the top see a little icon for Internet Explorer, see the words Internet Explorer dash, and maybe the name of the web page that you're looking at. That is called the title. And the dialog box has a title as well. And we can specify what that title is, otherwise Java will make one for us. If we, after the message, if we put in a comma, and again put the title in as a string, so that means it's going to be in double quotes, we can specify a title name if we want. Box type is sort of a special item. And there are a couple of different options for box type. We won't really be using it. Again, this is one of the two optional pieces of information we can give this command. And the box type allows us, there's an icon on the box. We'll see in just a minute. This is a sample input box. The message that I provided was enter Fahrenheit temperature. This box doesn't have any owner because you can see there's no windows associated with it. The name of the box, the title of the box is input. So where I had box title in my example, I would use in quotes input. And then see this question mark right here. This is what the box type would mean. The box type allows us to specify what this icon is, among other things. If we want to display output using the JOption pane dialog box, we would call the show message dialog rather than show input. Show message dialog is a one-way dialog. It doesn't ask the user for any input. It is just a window with a message on it and a number of buttons. Again, we need to let it know who owns the window. In most cases, this is going to be null. Again, that's a keyword null, N-U-L-L. There'll be a comma, and then the message we want to display is either the value of a string variable or the literal string. Remember, literal strings are in double quotes. Again, we have a box title and a box type. Those two items are both optional, and for the most part, we probably won't be providing those. This is an example of a message dialog. Again, you can see here with the name message, that's the box title. The icon here is the box type. Show message dialog has a default. This right here, the text, Fahrenheit temperature is 212, Celsius temperature is 100. This is the message that we want to display. And most message dialog boxes just come with an OK button. that sort of wraps up dialog boxes. We've pretty much talked about input. We've talked a little bit about a new output function. We've talked about two different ways of getting input from the user. I realize it's been kind of a lot in a short amount of time. We're nowhere near done yet. We're only about halfway through the lecture. But I want to switch gears a little bit because this relates to input from a dialog box. Dialog boxes give us their input back as a string. That means the user could enter a bunch of numbers, but it's still going to come back as a string. We need to convert that string of numeric characters into a numeric value if we want to use them for anything. For example, let's say we're asking them for two numbers to add together. We can't add strings together. When we use the plus sign with strings, we end up with what's called concatenation or consecration, which basically means we're just going to stick the two, we're going to connect the two together and display that. And that isn't always something that we want to do. So when we may mean addition, in those cases we can only do addition on numeric values, so we need to convert it to a number first. And we're going to do that using the wrapper classes. I'm just going to go over some, every numeric type has a wrapper class that serves the purpose of converting a string into a numeric value of that particular data type. So for example, byte.parseByte would give us back a number suitable for sticking in a byte variable. Same thing with short.parseShort. That's going to take a string and give us the correct numeric value that is suitable for sticking in a short variable. Integer.parseInt. This one I think is probably the most misleading because both bytes and shorts and ints and longs are all integers, but integer.parseInt gives us back a numeric integer suitable for being stored in an int variable. The long, again, gives us the input back, the numeric input back as a long, suitable for storing in a long variable. Float.parseFloat, again, same thing. Needs a string to do its work, and it's going to give us back a numeric value suitable for being stored in a float variable. Same thing with double. It's going to, again, take in a string and give us back a numeric value suitable for being stored in a double. Now, the double data type is a lowercase d. The double wrapper class starts with a capital D. There is a difference. Please make sure you're using the right one in the right situation. I think at this point it's probably safe to get on to making things look pretty. We've talked about the various input types. We've talked about the scanner class and getting input from the command prompt. We've talked about using dialog boxes to solicit input from the user. Since that dialog box gives us back nothing but strings, we've talked about how to convert that strings into a numeric value should we need to do that. We've also talked about displaying data in a dialog box. Now I want to turn our attention to, when it comes to displaying data, how can, regardless of whether we're using a dialog box or printing at the command prompt, how we can make that look pretty. The first thing that we're going to do is look at formatting the printout at the command prompt. We've got, in addition to all the other functions I'm going to talk about, we have one function that is just perfect for doing some sort of controlling the format at the command prompt. I'm going to tell you right off the bat, this is functionality I don't use very often. I can do what I want with the other two formatting functions we're going to talk about tonight, but I would like to introduce you to this. I know it can be a bit complicated to use. I think once you see it in action, it'll make more sense, though. How does printf work? Well, it's system.out.printf, just like it's system.out.println. Printf, however, allows us to provide a string, and in that string provide something called a format specifier rather than concatenating our variables in between. That format specifier allows us to set aside a total size, a total block of characters that can be taken up by the value of our variable. It also allows us to specify some formatting options, like a minimum number after the decimal point. Our key that we have, that when we're using printf, that we have a format specifier and that it's going to be relying on a variable to get its data, is when you see something in that printf statement that starts with a percent sign. The percent sign is what we call the format specifier. The format specifier has a particular format. It's going to be the percent sign, a numeric value, and then a letter. The letter stands for the type of data we can expect. The number, there could be a number or a number, a decimal point, and another number. And the number by itself stands for the total number of spaces this value can take up, and the total minimum number of spaces this value is going to take up. If we have something like 6.2, like percent sign 6.2, that means that it's going to take a total of 6 spaces up. 2 of those spaces are going to be reserved for digits after the decimal point, with one of those spaces being reserved for the decimal point. And I've got some examples here. We can take a look at them. Inside a printf statement takes a string and a couple of other pieces of information to do its job, to know what to do. If you see a percent number and then a D, what that means is that, like for example, if I see percent 60, the percent sign alerts me and alerts Java that I have a format specifier. The 6 says that this value is going to take up 6 spaces, no more, no less. If we're under 6, it will provide leading spaces. If we are over 6, I think it tries to fit it in. If it can, it hacks it off at 6 characters. The D lets us know that it's an integer. I thoroughly realize that these letters do not conform to the data types that we talked about. You would think that an I would probably be better here than a D, and I would happen to agree with you, but that wasn't how the language was designed. If you see a percent 6.2f, what that means is, first of all, the percent sign tells us that we see a format specifier. The 6 says we get a total of 6 spaces for this value. The 0.2 says we're going to have 2 digits after the decimal point, and the F tells us it's going to be a floating point or decimal number. And when I said these are easy to get confused, you would think decimal D, integer I. No, that's not the case. D is integer, F is decimal, or floating point. If you were to encounter a percent sign, a numeric value like 6, and then the character S, what it's saying is, first of all, the percent sign says, hey, format specifier, pay attention. The 6 says I need 6 spaces or 6 characters, and the S says that it's going to be a string, which means it could be a long character, a string of characters. The last one, of course, is percent a numeric value and C. In this case, the example that I have on the slide is percent 3C. Percent 3C tells us that, first of all, the percent sign says format specifier, so pay attention. The 3 says I need 3 spaces to display this character, and C says that it's going to be a character. What will happen is that if the character does not use 3 spaces, and remember, if we're talking about a control character, it may very well take up 3 spaces, even though it's all one character. There are symbols that go along with it that make it up. What that's going to say is that for every character, basically, there's going to be 2 leading spaces and then the character, simply because anytime we don't have as many items as we need spaces, it is what we call right justified, or everything is lined up to the right hand side of the block of space that we're looking at. For example, if I have the following code. If I create a double variable, remember that's going to be a decimal value with 16 to 17 significant digits, or 16 to 17 digits after the decimal point, and I'm going to assign it the value 20.5. Then I'm going to use system.out.printf, and I'm going to print the string total colon space $% 10.2f, comma, and you'll see then my variable price. What this says is when we get to the printf statement, we are going to print out total colon space $. The % tells Java we have a format specifier. It says that you're going to be allowed to take up to a total of 10 spaces. We are going to pad those spaces with leading zeros. We are going to have 10 spaces to work with, and not pad those spaces with leading zeros, I'm sorry, pad those spaces with leading spaces. We are then going to reserve 2 digits for the decimal point. We're also going to reserve a space for the decimal point. And then where we see that % 10.2f, we're going to display the value of price in a manner that is consistent with that format specifier. And what you see below under output in the red box is what would result. What we end up with is total colon $, and then a total of 5 spaces, then 20.50. And you may be thinking, what? There's only 5 leading spaces. Didn't you say to take up 10? I told it that the variable and the leading spaces should take up 10 characters. Well, 20.50 gives us 5 characters. 20, the decimal point, 50. That gives us 5 characters. That means we have 5 characters of leading space. And so what we end up with is what you see on my screen. That is not the only way to format numeric values. That is particularly useful at the command prompt, though I find myself not using it very often. It doesn't work for dialog boxes because dialog boxes call the show message dialog rather than a system.out.print function. In this case, we also have the number format class. The number format class it lives in the java.text library. Again, not one that's included. We have to include it in our program ourselves through use of the import statement. And the functionality provided by the number format class pretty much allows us to create a number format object, or for our purposes right now, a number format variable, and then ask the computer how currency or percentages are formatted based on the computer's current setup. There is a command called format that we can use. We can call from our number format object or variable and we supply it with the number that we want formatted, and it gives us back the string version of that number, perfectly formatted as either a percentage or a currency value. Now keep in mind, this isn't the only thing that the number format class can do. These are the only 2 things we're going to be able to touch on in this class. You can look this up in the Java Development Kit if you want some additional information, and I'll include a link to that in the resources section of our Blackboard website. If I have, for example, again, I've created a variable called price. It is a double, so 15 to 16 significant digits, and 20.5 is the value I've stored in it. What you see in the next line, number format currency format equals number format dot get currency instance. What we're doing here is we're creating a number format variable or object called currency format, and we're setting it equal to the results of number format's command get currency instance. What that does is go back to the operating system and say, okay, tell me how you currently format money or currency. What you'll see in the next line is I'm calling system.out.println, printing total colon space and then the value of basically the result of the format function or the format command that I called, um, and I supplied it with price. Excuse me, I'm sorry for coughing in your ears. You can see the result down below, where under the output section where it says total colon space, and then we'll see a $sign 20.50. We did not need to tell it to use the $sign. We did not need to tell it where to put the period. If we had thousands or millions or hundreds of millions of dollars, or billions, we would see commas in the appropriate places automatically. We don't have to tell it to do any of this. What happens is it goes to the computer and finds out the correct symbology to represent dollars, the correct punctuation to put to represent fractional dollar amounts, or in the case in the United States, cents. So it will go out and find all of that information for us if we tell it to, by setting things up the way we have in this example. We will get some practice with this in class, and you can read about this a little more in your book. Again, this is just another example that shows you that it will automatically put in the correct commas in the right places. In this case, we have 1,000, 1250.00, and when we call currency format and set everything up to display it as currency using the number format classes functionality, we will get $1, 250.00. Again, it asks Java asks the computer, how do you format the numbers? Where do you put the commas? Where does the decimal point go? What kind of symbology or what kind of symbols do you use to represent dollar amounts in your country? And every country is different. If you cycle through your settings, and on Windows X or Windows 7, it's hard to do. Windows XP is a little easier. The Mac's even easier still. You can see examples of how everything from dates to currency percentages and things will be formatted. This example uses percentages. What happens is that we call the number formats get percent instance. It goes out and finds out how percentages are displayed in this country or in this location. And in the case of the United States, we print a percentage as a whole number with a percent sign. So 0.5 or 0.5 is equivalent to 50% because it's half of 1. So we can just supply it with a decimal value and it will produce the correct percentage. Basically what it does is multiply it by 100 and slap a percent sign on there. And it does that for the United States. It might do something different in another country. While number format sort of sticks us, for the most part, we're going to deal with number format only in number format and decimal format, or number format for dealing with percentages and for dealing with money. The decimal format class is completely different. It allows us to format numbers using a pattern that we set up. We get to decide the pattern. Again, from the java.txt library, this is stored right next to number format. And ignore the title on this slide. It's not number format. It is how does decimal format work? Well, it's pretty easy. We create a decimal format object or variable. When we create it, we have to tell it the pattern that we want it to follow. What numbers are required? What numbers are optional? Do we want commas? Do we want decimal points? That sort of thing. We have kind of a little chart here of characters that we can use when setting up our formatting. The 0 says it's a required digit. That means if the number doesn't have if the number doesn't go out that far or doesn't have that any numbers after the decimal point, we're going to supply a 0. We want to see something, either whatever value the number is or a 0. The dollar sign or the pound sign, or what looks like the tic-tac-toe board, if you hold down shift and press the number 3, you'll get one of those, is a little bit different. This particular character in a formatting string for the decimal format class would indicate that if there's a number present at that point in the value, go ahead and display it. If it's not, just don't display anything. You don't really need to display anything. We have then can use the period as the decimal point separator. We can use the comma as the comma separator. There is no sort of validation to say, oh, no, 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 this is not how American money or United States money is displayed. No, 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 this is not how we display Chinese money or French money or German money. This isn't how we do it. There is no validation for this. This is all up to you to decide. We can also display percentages. It will take whatever the value is, multiply it by 100, and display the percent sign along with it. If we look at our code from earlier, and we take that 0.5, we call number format. Now, I named my number format object or variable pattern format since it's allowing me to set up a pattern for formatting numbers. Equals new decimal format. The new got cut off when I converted the slide over so that I could display it on my Mac. The new got cut off, but it's pattern format equals new decimal format, and then inside the parentheses for decimal format, we're going to provide a literal string that consists of any characters we want displayed every time we call the format command. The optional numbers through the use of the pound sign, and the required numbers through the use of the 0, along with commas and decimal points if we want those to be displayed as well. And we can see some output from the statements above. Basically, if I feed in 0.5 and print out the result after I call the decimal format's format object, based on the formatting we have, the value in the hundreds place, or that would be displayed if we had items 100, a numeric value that was 100 or greater, is that first value there to the left. If there's a value there, we'll display it. If not, we will leave it according to the symbol there. We'll leave a blank. Same with the tens value, or the second to the left value. And then we start seeing 0.00. That means that even if there is no ones column data, push 0 or enter display 0. Display a decimal point, and then display whatever value is provided, and if no value is provided, press or not press, but display 0. And again, you can see the result of that. 0.5, instead of printing out as just 0.5, displays as $0, because a 0 right before the decimal point is required unless there's a number there to replace it. We have our decimal point, then the value 5, and since we're also saying, okay, right out on the right side of that decimal point, the second number over, if nothing is there to be displayed, I want to display the number 0. Again, this is going to result in a string. You can see on the next slide, I've got a bunch of optional numbers in the formatting, along with some commas. And if we look at the end result, I'm not going to follow this code through line by line. I think you can handle that. It's going to result in 11,000 because I have the number 11,000 up at the top. I'm running it through the format. It's applying that format pattern that I provided, which says that anything in the thousands or anything in the millions, if there's millions, then display them. If not, don't display anything. Display a comma again if needed. Display the thousands if needed. Again, a comma if needed. And then display hundreds, tens, and ones. And then, of course, if there's values after the decimal point, display them. If there are not, don't even bother. Again, we've seen some code examples already where we've used utilized one of these packages, one of these 2 or 3 packages we've talked about, either the java.util, javax.swing, or java.text. We've already seen this, but in order to do that, we need to utilize what we call an import statement. The import is a keyword. It tells Java that an additional library or package is going to be needed, and then right after that, we put a space and then the name of the package that we're looking for, right down to either the name of the class or a wildcard. We're going to end that statement with a semicolon, and you can see here the import statements, one for java.util, one for java.swing, and again one for java.text. And we'll see those utilized in our programs that we'll talk about when we meet again in class. This would be the point where if we were in class, I would ask for any questions because we've covered a lot. I mean, we've talked about getting input from the user at the command prompt using the scanner class. We've talked about getting input using dialog boxes, displaying data using the dialog boxes. We've talked about various ways to format input or format output to make it look pretty. We've talked about using Java. We've talked about using the printf function. We've talked about using the decimal format function and the number format function. And of course, to use a lot of this stuff that we've talked about today, all of it is not available to us by default. We have to let Java know we want to use this functionality by importing various libraries or packages. And we've also looked at how to do that. It's a lot to take in when we haven't really had an opportunity to sit down and practice it yet. I will be reviewing this stuff as we practice in class, but if you have any questions in the meantime, of course, feel free to contact me before class. It'll help me sort of gauge how much you guys are getting this, and then we can, maybe have a little pre-discussion on how this works when we get into class, because now we're starting to get into some complicated topics and some, well, you might use this if and you might use that if, and we're starting to get into areas of judgment where you have to decide what works best for you or what you're most comfortable with. So take a look at this, make sure you take a look at your book, and I will see you in class where we will discuss this even further. Again, feel free to email me if you have any questions on this presentation.